Welcome back to another session down the rabbit hole with Building Inspector Steve Nason. As you know, in these sessions, we'll dive into or go down the rabbit hole and to see various code items. Today's session is on fenestration, flashing, insulation, and code compliance. Okay, so we'll go through these a little bit at a time. Okay, as you can see in this slide here, the certainly the construction methods, the materials have changed since the older house was built and the newer house built. The older house has more water absorbing characteristics. The older house just doesn't like water. So there, and then we've learned lessons from both these houses here. So, all right. Now, the codes and standards that we talk about are the national, of course, the National Building Code here in New Brunswick. We use the 210 code. Other provinces, they may use a different code, but basically they're all the same with a few revisions. Okay, within the building code, we have it's reference to a NAF standards. Okay, and that's a North American Fenestration Standard, commonly known as NAFs, and that's the guideline for testing, evaluating, and performance of windows, doors, and labeling of fenestration products. Okay, within that NAF standard is a Canadian supplement. Okay, the biggest thing with that supplement, which gives us a little bit more stringent, is the definition of water penetration differs from the definition in NAFs, air infiltration, exfiltration rating, and the key one here is the water penetration resistance is separately from the performance grade. Okay, so that that Canadian supplement adds a little more strength to it. Now, the other standard that we look at within there is the window and door installation standard. Okay, that talks about the standards of new doors installation. Those things. So, those are the two standards that are referenced in the National Building Code. Okay, now fenestration requirements. Why do we have fenestration requirements for windows and doors? Okay, it's fairly simple. Okay, we're dealing with 10 meters in height. That's or above. So there's a couple levels, and there's the first one is 10 meters in height. You've got wind blowing against a building, which is typical. Wind, rain, water blowing, and it bounces up there, heads up the top of the building, and then that creates a stack effect, which causes negative pressures in the building, causing air and whatever. So that's why we need to have a fenestration standards. Okay, that's pretty simple. Now, within those standards, you'll have various different classes, okay? R is for 1 or 2 family homes, right? And normally the minimum for that is a PG 15, and as you can see, a minimum test size. We'll get into that in the next one as we go down. Next one is light commercial, right? They're low-rise, mid-rise buildings. And as we go down through these, as you can see, the minimum performance grade is increasing, and so does the testing size increase for those. So you can see the next one is PG 30 is a heavy commercial used in low-rise and mid-rise buildings. Heavy use expected. Then you got an AW, which is a severe duty. And again, that PG rating moves up. The minimum PG rating moves up to 40. But for the building code perspective, for us building inspectors, we only have to worry about the performance class, which is R, residential. Okay, so as you can see, what happens with that is your performance grade starts to go up, and your testing, your minimum testing size moves up. Okay, as you can see on the other slide, it's light duty to heavy duty. Okay, so that's it. So as a building inspector, we really only have to worry about for the minimum for R. Okay, the other thing that we need to know is the terrain, right? As the picture shows, open terrain or rough terrain. Basically, open terrain would be the end of a field, lakes, wherever the wind and the rain can get at it. Rough terrain's like a subdivision, you know, where it's sheltered by trees, houses, anything that'll buffer that wind or rain in this case. Okay, now the other one is that location is important. Okay, as building inspectors, you need to know the location because as you can see in this slide here, the performance grade. You can see the performance grade here is a 25, and this one minimum 25 and 35. and it varies from all around the province. So what you'll see here is you'll see this one here in Alma, okay, on a 10-meter high building in an open terrain. The minimum performance grade is 25, and the minimum water penetration resistance is 260. So, and then you'll see the R class up here. And now, okay, and then if you go up to, where are we at? Edmundston, 10 meters in height, right? Open terrain, and the PG is down, R class down to 20, and the water resistance pressure test is 180. So that's, as you can see in the slide, its location, and it'll vary. So you need to know your location primarily, and so there's not one rating for the whole province. It's one ratings for different areas, and that's all based off your climatic data. Okay, now if you want to just, I'm going to keep reinforcing this water penetration resistance ratings, right? This one is separate from the PG rating, so I'm going to keep reinforcing that as we go along, because it's a hard one to think of. Now, this is one I think is testing of fenestrations. Okay, it's only a window or door until it's been tested. Then it's a fenestration, sort of a bit of a play on words. Okay, now the units that are tested, single units are like a one single unit. That's pretty self-explanatory. This is a single unit. Composite windows are a mold unit with a common frame. So if you put your finger down here, you can watch run all the way around here. Okay, and that is a composite window. Now this would have a mullion here, but they normally call it a T mullion. But if you roll it all the way around, this is one common picture frame. So that is a composite mold window. Now combination windows assemblies are a little bit more trickier. Okay, as you can see, each window's tested performance. Then these mullion bars right here are tested. Okay, and they're the ones that sandwich these units together. Okay. So they test this one, a mullion bar, and this one. As you can see, all right, in this picture here, you get this window was a PG 30. The mullion bar is a 25. This is a PG 20, this window. Okay. And if you look at all these three numbers, the lowest one is a PG 20. So this whole unit would get rated at a PG 20. But these mullion bars are tested structurally tested, and they're also tested for air and water. Okay, so that's a combination unit. Okay, now the window testing size, right, normally, as you can, the minimum I think was for an R was a 1200 millimeter by 1200 millimeter, or if you've tested an example, it would be a 4x8 window, right? You can make a window that's smaller than that, right, with the same ratings, but you can't make a window any bigger than a 4x8. So basically, what size you're tested with, you can make it smaller, but you can't make it any bigger. I don't know if that makes any sense. So if you can see here now, this window here, let's say that would be 4 feet by 8 feet, and this one would be a 2x2. That's okay. So we just got to watch that one. Just make a note of that and just watch that testing size. We'll get into that. And out of that, you'll see a testing report. Within that testing report, they've reported that this window here I'm sorry about the company, but that's just one that I had in stock. So you see a PG 40, tested size, positive, negatives, water penetrations, air penetrations. Okay, so that's been, and that was done by a company called Arians, and there's lots of companies that do these various testings. So you can see the tested size, you can see the 40, and this is the tested size of this window. So they could have made a smaller window on that. And so you can see the positive, negative, and water penetration resistance test on that window, which is a 400 air infiltration. We'll talk about that a little bit later, but the air infiltration rating for an R class is, the minimum is a 2, and this is a 3. hopefully we'll find that in a different slide. Okay, so we need to know, that the performance grade, air infiltrations, as I said, A3 is better than an A2, and I'm being told that the A2 is a minimum one for your Energy Star. So then your water penetration resistance test, okay, watch this number because it's unique to each location, as I said earlier. So now if you went into the Fenestration Canada website, and I can put a link below on that, so you do is you pick your province, your area, in this case St. John, Part 9, 10 meters in height, rough terrain, and then it'll calculate the numbers, okay? So in this case here, is that this is a minimum of performance grade of 20 with the water resistance test of 260, okay? Now, as I said earlier, those two numbers are decoupled, okay? So if you look at this one, if they weren't decoupled, what you'd have here is that this would have been a minimum of 20, would have a 150 water. So you can see this water resistance test is higher than the performance if they weren't recoupled. So we just go back here. So all we'd worry about here is that it's a performance 20, a 260 on your water resistance test, and at minimum in this case it is an A2 air infiltration exfiltration rating. Okay. All right. Then I just marked that down in your code book, and you should be good with that. That's pretty simple. Now the energy stuff, we have 936 in the energy, 936.27. It covers requirements of building code. But truthfully, if we look and make sure it's Energy Star for your zone, 9 chances out of 10 you're all good. You really just want to make sure it's Energy Star. Right, and I know there's other minimum requirements for performance and air for energy, to meet the Energy Star, but for the sake of energy efficiency, I would just use the Energy Star. Okay, labeling. Okay, labeling is a bit sometimes can be a bit confusing. You got one label here required on a composite window. Okay, as we said, it's a composite window. So that's tested as one unit. You need one label required. Now, when you get into the combination ones, all right, it's a little bit more tricky because you get 4 types of labeling on here. Okay, but the key for this stuff is to look for the overall performance ratings. Okay, sometimes they'll label each. As you can say, you got an overall performance here. So this one here, you've got a bunch of you got one for this window, one for the mullion, one for the window, one for the mullion, one for the window, right? But you got to look for the lowest number or the overall performance. That's pretty simple. Okay, so as you can see, in this example here, they've got the overalls and all of them. But again, you either want to look for the overall performance or you want to look for the lowest rating of the labels on that window. Okay, so what you'll find on a label, you'll find it's Energy Star up here. In this case, it's an R class window, okay? And you'll see the performance grade, which is PG20, tested size. So that tested size, if you look at that tested size and you go measure that window, that should be smaller than that tested size. That's one I said you got to watch for right there, because sometimes through labeling or whatever happens, that may be bigger. So you have to watch that. So that window should be smaller than that if it's a composite window. All right. And then you've got air here, and you've got your air, and your water test is 260. So that's a pretty simple label you'd find on any window. Okay, energy labeling. Okay, now you'll see it has all the evaluations here. It has your zone on here and your certification mark on it. So, but normally, as you'll see a okay. I'm just going to scroll back here. What you'll do is you'll see a label window and one of these windows all together normally as a 2-part or 1-part window. So now with the energy labeling, sometimes it's very confusing because I didn't realize this, but you look at the NAFs require one label for each piece of glass. Okay. Now this window here is a composite window, so they could have had just one label here, but the energy says, hey, you have to have a label here and you have to have a label there, which kind of makes you say, okay, what's going on here? Anyway, so that's how that works. They probably could have put an energy label up here, just an energy up here and an AFS label and a combination label type here, but they chose to do this. So sometimes it gets a bit confusing. Okay, now we're into installation of windows and doors and skylights. Okay, there's only two types of windows. Windows that leak and windows that will leak. Eventually in its life it will leak, and that's by Joe Seabrook, a building science guru actually. As you can see, and flashings around windows and water and protection of water is key. As you can see what happens if you don't install a window, put the flashings in there correctly. Lots of damage there. And if it doesn't dry, it will die. It's just a matter of that. If it stays wet and it doesn't dry out. In today's houses, like that first photo, these, you've got very water sensitive sheathing materials, which don't like water. Okay? And most of the 80% of lawsuits are from warranty claims. Now, water resistance barrier, okay, you can have either a sheathing membrane, which is here, or an air barrier. Depends on how your contractor has installed this. Okay, so you can do the WRB is either a sheathing membrane, which protects the sheathing, or an air barrier. There's two different methods of installation when it comes to that. Now, this is a window. Sometimes contractors are what you'll call as a fully adhered, where they'll cut back the WRB about 6-8 inches for the flange, okay, and then caulk it right into here. So that's a fully adhered window, okay. Or you take a partially adhered one where they'll take this WRB and wrap it around, right, and adhere the window flange to that, okay. But the key with this is either one of these methods, this top flap always has to be up, okay. Now the code or the installation standards says that the water resistance barrier, the WRB, right, is to be continuous with the fenestration product. So either one of these applications will make that continuous. Okay, water resistance barrier. Okay, I see a lot that the tapes are not flashings, but they're sealing tapes. Okay, I've heard a lot saying, well, we've taped the window to the OSB or whatever there. No, that's not a flashing, okay? And you got to watch some tapes like they'll eat a vinyl window. So if you're on the job site, you may want to mention to the guy, or if he's using some brand you not normally see, they will tend to eat certain vinyl windows, okay? And red tape is for sealing around the house wraps. It's not to be sealed around windows, right? And that's typically where you go from house wrap to house wrap. Okay. Then now there's out in the market, there's a fluid applied sealing. In Atlantic Canada, I haven't seen a lot of that, but there's a lot of uptick on this sealing. As you can see how they've taken a fluid applied sealing around this window, and they do seal the fluid around here, or they do tapes. But the fluid applied sealing, we haven't seen a lot here in my area. Okay. Now, Sub-Sill flashing, that's a sill in the rough stud opening, okay, before you put your window or door in, okay. That is required when you have a second plane of protection, okay. If you're not sure what a second plane of protection is, that's that airspace that you have between the sheathing membrane and the siding. There's an airspace in there. So when the code calls for a second plane of protection, right, you have to put in a Sub-Sill, which is at the bottom before you put your window in. It's the bottom of it, and it's all. But they also tell you in the standard that on the installation standard, it has to go under all doors and under all combination mold fenestrations, okay, and in buildings that are greater than 3 stories in height. So these are the always ones that you always have to do them in there, whether you have a second plane of protection or not. So that's the always ones. Now, if you can look at this map of this spreadsheet of New Brunswick, you can see that, let's just go back to Alma up there again, as if you could, Alma or Woodstock or one of those things. Okay, Alma requires a second plane of protection, okay? Right, because that's all based on the degree days, okay, and your climatic data. Now, if you go into Woodstock, they don't need a second plane of protection, right? So they don't need a Sub-Sill. Okay. I'm just going to go back here a little bit more and say, I don't know how this, if you look at the driving wind and the rain, the average rainfall, okay, if you look here, they got 36 inches of rainfall, okay, yet they don't need a Sub-Sill flashing or Sub-Sill protection. That doesn't make a whole pile of sense, but again, as building inspectors, we have to do what the code requires us. But, you know, I threw in the average amount of rainfall in here just to give you an idea, because again, it's rain and wind really affect the windows. But again, is that in some cases here, you got to know here in Grand Falls, you got 36 inches of rain, okay? And then if you go down to Moncton, I think here you got you got 39, so you're only talking 3 or 4 inches of rain, and that's nothing. And today's climatic change, you know, it's probably a good idea that they put that Sub-Sill flashing on the bottom. But again, as building inspectors, we can only push what the code requires us. Okay, now these are code and standards. Okay, so what they tell you here is, I'm just going to go through it with you, is that it's a water impermeable membrane at the bottom. Okay, goes up 6 inches up here, right? Lapped, okay, and it's installed over a rough sill. So you get a slope sill that's rough. So what that is that's to allow the water to drain out there should any water get past that, okay, in there. As you can see in this picture here, this green board here is your slope sill, okay, and it pitches to the outside of the window. Now the other one we see is a back dam here, which I don't see too many of here, but they put a wooden back dam in here to stop the water in there. I have not seen this. So what you'd have is your WRB up 6 inches into the back dam. Okay, so that stops any water, and we haven't seen, because most of the guys will foaming around there, but I'm not sure. And I've tried to look at the standard to understand how this works, but it's within the standard, and so that's the back dam. As you can see how this got a bit of a flex wrap up here, it turns up. Okay, then this one here's the bottom of the door, which would have a welded flange. But now the key to remember is when they put the flange in here, shouldn't be cocked at you or fastened. If you're going to cock it, you run your bead of cocking 2 inches, skip an inch, just sort of what they call skip cocking. Okay. Now the other thing we see in here that the standard requires, okay, is the use of a backer rod. Okay, and that backer rod is right there or there, you know, it wraps all the way around. Okay, and they want it caulking. Okay, and so that no air or water will get past that and it'll drain out this way. I've not seen a backer rod being used in window installations, maybe in a commercial application, but no, and that's just the standard. Now where that goes is you can see the window planing windows here and the backer rods there. Okay, so that's out there, but as I say, most building inspectors, you don't see the backer rod being used. Okay, now shims. Now they've got to be hard enough so they don't creep out, good thermal separator, resist decay, allow for anchoring through the shim, and hard material can be used. Generally, I've been seeing a use of the AZAC type of material because the shims are hard to find, but a lot of the guys are using an AZAC block. Now, cedar shims can be used, but they can only use if they're made as cedar shim stock. Now, the building code does talk about using treated plywood at the bottom, Normally don't see a lot of that because people are just that, they don't like to see that treated plywood under the window. So once again, that's what we'll say for material is the AZAC. Oop, sorry about that. Oh, one more. Okay. Now, oh, we got a little. Okay, there we go. Shims are okay. Located at the corner, rotation, so they're there to minimize the deflection, rotation of the frame. Okay. Normally, they're located at corners, crank handles, evenly at the bottom, under mullions. Okay. And the way that I look at this is that they act as a load transfer blocks for the weights that are coming down. Now, as building inspectors, I wouldn't be going around telling people where to put the shims because there is a manufacturer standard should rule, and there is also a shim placement within the standard, the installation standard. So, but it's just good to know that what we need is, corners, crank handles, and evenly on the bottom. So if you don't see any shims in there, you may want to ask, to the guys. Now, the other thing that I don't have is that OSB shims, we see a lot of this, okay? The OSB is used for shims. That doesn't meet the requirements, and that's because basically all that is glue and sawdust, okay? Which will absorb any moisture, water. Okay, now we're into head flashings, okay? As we've seen in the first slide, if you don't put the flashings on there, what happens, okay? All right, so the code says, again, that you need a flashing if you have a second plane of protection. So that's key. So if you're required to put a sub-sill, you're required to put a head flashing in there, and that's all based off that second plane of protection, which is due to the climatic data. Okay, except what happens is that if you've got a 2-foot overhang, and you're within 6 inches of the overhang, you don't have to put a flashing, which is self-explanatory because it's protected. Okay. Now, once again, we talked about a few minutes. We talked about the water path and see how that water would go down there and flow down there. Okay, and that's very important because most cases that flashing over top of these windows is more important because in Atlantic Canada with vinyl siding, we don't require that second plane of protection. Now, I get a lot of guys that'll say, I've taped all the way around here, okay? But I'll show you here in a second what happens to this tape, okay? Or a little bit of a fun video. Let's see if we can go this way. Okay, good. So what happens is with that is that the wall, the window may not leak for now, but the whole wall assembly becomes wet and saturated. I said if it doesn't dry, it will die. So I don't believe that I try to say to the installers that the tape just doesn't work. You need to put a flashing on top of it. Now the code does talk about flashings, and the standard does talk about flashings. Okay. So what they have to be is they have to be pitched 6 degrees, right there, and they have to extend beyond, 19 millimeters. I believe that the standard says 19 millimeters, the code says 10 millimeters, with a 1-inch end down, and go up behind the flashing 15 millimeters, or 2 inches up behind the WRB, okay? And the code also says that you have to have a 5 millimeter offset, just enough to kick it out towards the, kick it out away from the window, okay? Because if they don't, the water will tend to curl back in and run right back down to the window. So that is the standard and the code requirements for an end flashing with an end dam. And end dams are required, okay? You just can't have a flashing, you have to have an end dam with it. As you can see, there's a code compliant flashing with an end dam, okay? Kind of a bit of an ugly window, but we'll talk about that a little bit later here. Okay, now I get guys on the job site say, oh, it's so much work to do a flashing, right? Well, I asked the guy at the job site if he'd show me, and it's pretty simple. Okay, so look. So there you go. He's cut the width of the height of the end down. Okay. Takes his duckbill pliers. Gives a little bit of a bend. Boom. Up you go. Then he comes around and he's got to crimp that, tighten that end in so the water doesn't leak. And there, he's done. How hard is that? Now, the only thing with this one is that he probably didn't get his out here. He should have had a little bit more of a kick out, all right? But that just generally gives you the idea of how easy it is to build one of these. Okay? Okay. Now, window trims. Most cases, okay, flashings and all those were designed to work with a full brick mold. Okay? And that's typically what you'd see in most of Canada. But in Atlantic Canada, we have these things called built-in J molding. Okay? And it's only unique to Canada. And watch this. So what happens with that is that the siding can come in here, tuck in here, so you don't have to J it, right? And rolls up here. What that does though is that creates a huge funnel at the top of the window, right? Well, guess what? The water run down here, run down there. So if you've got a how wide that window is, you've got a huge funnel over top of that. See, see how that would. So the manufacturers come out here or whatever and cut this out to allow the siding. Bad idea, but anyway, that's only unique in Canada. So, okay, where I am the building inspector in here in Rothesay, we have an alternate solution for window flashings. Okay, so because again, as I showed you the ugly one there with the 1 inch up the out. So what we do is I allow, or the town, as a building inspector, this still has to go up the 50 millimeters at the back end, okay? I want to see a 1/4 inch gap with a 3/8 end down in there, okay? Now that would be on a full brick molding window. Okay, so now the other part is it's a little tougher because again, as you can see, this has gone up behind the WRB. We've got the 3/8 end down. They got a little bit of a notch here on there, okay? But this has to wrap right around to hide that hole because of that built-in J, okay? And then see, this one still doesn't have the kick out, but it's a work in progress. Anyway, any water that would run down, right, would get out, okay? And the slope here is just a bit harder, but okay. So you can see how this one fixes this window is wrapped around. Okay? Now the other one I get here is another. I call it the short version. So what they do is they treat the, and you'll see in the next slide here. They treat this frame all the way around here as the window, and they don't worry about these things here. So the flashing will come to the edge of the inner window, okay, in there, and they can then run their siding all the way up. You can see how this one works up here. My thought on this one would be is, okay, keep the top brick molding in, side of it gets cut down 1 inch, open on the J's on the side, and that way you can go up here with your siding. You may have to put a little something in here, I'm not sure, but then you put a full flashing up here and you don't end up with that hole there. That was my thought on it, but I haven't seen any traction on that one. Okay, so now also what we do is that we require, the town of Rothesay requires a quote sheet before we all issue a building permit. Okay, that indicates the performance and energy values, okay? And that's a better approach, okay? And, because sometimes you just don't get out to see a window in the field and check for labeling. So if you've got the quote sheet, which is a document saying, yes, we're putting these windows in, you should be good, okay? And we can work with suppliers and all those with information, okay? Okay, as I said, it addresses concerns. It's a legal declaration. Inspector may not have the time to do the field inspection. So the quote sheet is the best one. So this is a quote sheet from a company. So it talks about my NAFs. It gives me my tested size, all my criteria. There's a tested size. Water resistant penetration is 750. Okay, air level is 350. So I get all that information on that one quote sheet, right? So then if that window doesn't meet, we can have a discussion before the permit is issued. The other one you'll see is I'll get them, they'll send me the test reports or a spreadsheet or something, okay? But we get that before I issue a permit. The other thing I've done is I've sent out an advisory to all the folks saying, listen, this is the performance requirements, this is the energy requirements, this is what you're looking for in the label, this is your flashing, a little bit of QR codes in here, just so that the contractors or whoever know that this is what we're looking for. Now also, I've started something a little bit newer. So sometimes we get a windows that may be 6 or 8 inches bigger than the test size, okay? And the test size may be up as far as 70 or whatever, maybe up in the higher end, okay? So is that fair to the manufacturer to make them go and test the window? Probably not, because again, if that window was tested, right, that's not gonna drop from a 70 down to a 20 for 6 inches. So we have an alternate solution, that kind of reason for the alternate solution, and a little bit of talk, a little bit of there. And again, is that covers them off as long as they got the initial size tested. Okay, now the end game is consumers generally. Okay, Fenestration Canada spent a lot of money on time and effort, right, for their products for Canadians. So it's not fair to the consumers, really, you know, and Fenestration Canada that we're not checking for this stuff. Okay, now consumers are not aware of code standards. Right? They believe that when they purchase a window, it meets the code and standards. Okay? They don't know that. They just want to buy a window. Okay? And the guys, some of the suppliers, all they want to do is sell a window. So, and they believe the government or inspectors are looking after the compliance. Okay? So, and code enforcement throughout this whole Canada is hit and miss. Some guys won't inspect, some guys do. So I don't know. So moving forward, I take small steps with my contractors. We talk about it. We have education, all right, and I work with them as a team. They've come up with the alternate solutions for the end dams. They've come up with a short version, the long versions, you know. So I work with them as a group, and I'm always persistent with the message and compliance. So one guy has to do it where there's no one guy doesn't, one guy does. No, everybody has to apply to the compliance levels and try to keep it simple. It's not that hard. Use your quote sheets and just probably don't get into the weeds with this stuff. That's the easiest way, and try to just look for your 3 or 4 items on your windows, and away you go. And thank you very much.